Okay, so signing of Eiffel events. I think we touched upon this briefly this morning, or at least mentioned various security aspects. So I'm going to start with explaining how it works a little bit, and then we have one slight problem or unclear thing that we could. There are multiple options of how to solve the public key distribution when signing the events. So first of all, why should you sign events at all? Well, it depends a little bit on the architecture of your message broker and so on. We use a single broker, single exchange. Lots of people can publish events, everyone can read them, and so on. So one immediate problem is, how do you know who actually sent the message? Can you trust it? If it's a matter of test cases, it perhaps isn't that important. But if it's a matter of, is this artifact releasable to a customer, for example, that's a little bit more important. For that matter, what is the URI of an artifact, so that people can't, send any URIs posing as valid artifacts. So identifying who actually sent an event becomes very important if you care at all about security. So it's pretty interesting that it's been the lack of support for signing in tools in the ecosystem is pretty interesting, because this has been going on for quite a while, and it's apparently only in recent years that people have been paying more attention to security. So I hope we will see significant improvements in this area going forward. One question is, just identifying, authenticating who actually sent an event. Another question is, you need to have some kind of rule set. Who is allowed to send what? What should you pay attention to? That's not covered by Eiffel. Eiffel only covers the authentication, who sent the event. So probably I would assume that individual services would have to figure out for themselves and configure who should I pay attention to for artifacts, who should I pay attention to for confidence level changes, etc. I think most services won't deal with receiving messages from or events from that many senders. So I don't think we would have any complicated access control lists. So if we look at another example event with all the unnecessary stuff removed, it looks like this. So the addition when you do signing is things start happening under meta security. So first of all, you have meta security author identity. This is the distinguished name of the sender, identifying who is the sender, who sent this. And secondly, you have, and that's something you could specify regardless of if you're signing or not. Of course, if you're not signing it, people have the possibility of verifying it. You have no idea if it's actually true, but you could set the author regardless of the signing. If you do choose to sign, you have the meta security integrity protection with two keys. AUG for the algorithm, which is really a combination of the hashing algorithm and the signing algorithm. In this case, you would use elliptic curve with a SHA-256 hash of data. There are a number of other different options, but this would probably be a typical choice. And then the signature in just basics for encoding. There's a ... to the right there. The signature gets fairly long. Is not huge, but in many cases it'll increase the size of the events by maybe 50% or so. So that's a consideration when you're for your event repository, or however you're whatever you're doing with the events. Specifically, in the previous session was mentioned that you store your events in Elasticsearch. We do that as well, which we'll talk a little bit more about tomorrow. If you do that, make sure that the signature field is not indexed, because you're probably not going to be searching for events based on their signature. That's very unlikely to be useful. So how does it work then? Well, first of all, one annoying aspect of JSON is that there are many possible representations of the same data. So to be able to sign and verify the data, you have to know about canonical JSON, which is a, I guess you can call it standard, specifying how you should serialize data structures into JSON. So canonical JSON specifies, for example, that you shouldn't have any unnecessary spaces, and it specifies what escape sequences you should use. So in this example, the one on the left is not canonical JSON, the one on the right is. So we removed all the unnecessary white space, and also the Unicode sequence for the new line character shouldn't be used. You should use the \n instead. So the one on the right is on canonical form. These are, of course, equivalent to a normal JSON parser. It shouldn't matter which form you use, but when you're when you sign stuff, it doesn't matter. You hash the data, and the hash algorithm doesn't care if they're equivalent. They only care about what sequences of octets does it get. So it's very important to get this right, which is surprising how few implementations there are to get canonical JSON in different languages. I was a bit surprised by that. So some pseudocode. So let's look at how signing actually works then. This is an intermediate session, so this should be okay. So first of all, you have to set the identity to whoever you think you are. You would set the algorithm to something that matches how you're doing the hashing and the signing those algorithms. Secondly, you would set the signature to an empty string, because a slightly annoying feature of how signing works is that the signature or the data fields for the signature is included in the payload that's signed. So it's a bit of a catch-22. So therefore, we set the signature to an empty string first. Then we sign the data. So we put it on canonical form, we hash it, in this case we SHA-256, then we sign it. And then the result of that can be put into the signature field. Nobody nodding, please? Question, yes? Yes, the entire event is signed. And then we sort of, yeah, so we're putting in the signature afterwards. So it's a little bit unpractical. So you have to unwrap it in the right order when you do the verification. So if you look at verifying this, you would extract the signature from what's in the payload, and then you set the signature to an empty string, just like you did when you signed it. So you sort of restore it to what the event looked like before the signing. And then you can do the verification after, again, putting it into canonical JSON form, hashing it, and then you can verify it. So we have to do things in the right order, and yeah, it's a little bit tedious. And if the verification fails, of course, you don't really get anything. Yes, sir. Surprisingly hard to hear, actually.
Yeah, I hope it's better now.
Thank you, yes.
The author identity is hard-coded to distinguish names, which is defined in the LDAP specification. Why specifically DM? And why do you support more author identities, like, let's say, if you go for another identity solution than Active Directory?
Well, if you use Active Directory, you have distinguished names as well.
I was thinking, because if you move away from, for example, Microsoft at all, for example, you go to Google solutions or other solutions that don't have that structure.
Yeah.
Then I'm wondering why we lock ourselves to author identity. DN, distinguished names.
I don't know. I wasn't part of that discussion. I don't know, maybe if Emil is shaking his head now. I guess that at the time seemed like a good option.
Standard at the time.
Yeah, it was the best available de facto standard. Then I guess, I mean, you could, these distinguished names, they don't necessarily have to correspond to anything in reality. I mean, you could have a distinguished name that references a open ID identity or something like that. So it doesn't have to be sort of connected to something physical, to put it that way. We're just about starting signing events, and we're probably just going to make up something that is syntactically a distinguished name but doesn't exist in our Active Directory, for example.
So basically, it's a free text string in the schemas, or is it?
Schema-wise, it's just a string. Yes.
Okay.
We could. Yeah. So, are you asking? May I abuse this?
I'm an engineer. What can I say?
Yeah. Exactly. I'm guessing that writing a regular expression that matches all the valid distinguished names is probably not easy. So it's just a string.
Yeah. Okay. Thank you.
Okay. Right. So ecosystem support. The first part of the ecosystem that got support for signing was actually the .NET SDK a couple of years ago. When looking into this, I discovered the weird thing that I didn't mention that earlier. I should have done that. It is possible to include the public key in. Let's go back here. You can include the public key along with, I think it's inside integrity protection, which is a little bit weird because, I mean, if you include the public key in the message, how would the recipient know that this is the public key? I mean, it doesn't provide any authentication at all, unless you already know the public key. So it's not super useful. So the .NET SDK supports signing by including the public key in the event. So maybe not super useful. So that's probably a reasonable opportunity for making improvements. The Go SDK does not have any such limitations. It gained fairly recently support for both signing and verification. And it does not directly support inclusion of the public key at all. And also the Eiffel Broadcaster Jenkins plugin has support for signing outgoing events. Both, it separates the sort of system events that the plugin sends itself, like the activity events when builds start and finish, for example. Those are like sent by the plugin itself, as opposed to the events sent by jobs. There is a pipeline step that you can run to send any kind of event. Then you have to also specify the key, then you need another private key. Because of course, if anyone writing a Jenkins job could be able to send events using the same key as Jenkins itself sends the activity, then you could spoof anything that Jenkins would do. So we do that separation. And you use regular credential objects in Jenkins, so you could have separate signing keys for different folders of jobs, for example. I believe that works pretty well. So this is the thing I talked about earlier. How would a recipient know which public key to verify the events with? We had a community meeting about this spring and talked about the different options. And since then, I have completed the implementation of the Go SDK and Eiffel Broadcaster. So I've been doing some more thinking, and we're about to implement signing on a fairly wide scale. So I think we have a plan. But let's talk about the different options. Yeah, this is what I mentioned earlier. You can include the public key in the payload itself, sort of what the .NET SDK does. There is one way in which this is useful, and that's if you send, look at, if a recipient can obtain the first event sent by that sender, they can sort of assume that, yeah, this is the public key that should be used. They can then save that key and make sure that in every subsequent event sent by that sender should be by the same key. That's sort of similar the first time you connect with SSH to another machine. You get the fingerprint of that host key and you can choose to accept it, and then it will be saved for all subsequent uses. So that could be one method, this sort of bootstrapping. On the other hand, it's pretty, you have to trust the very first message you receive and how to make sure that that is actually trusted. It's doable. I don't know exactly how it's going to work in practice, but it's one way anyway. Another method would be to change the protocol and expand meta-security with the ability to include a certificate. That would make it pretty similar to how normal TLS works. Then the consumer would be able to verify against the certificate authority, and they would know, if I trust the certificate authority, I trust that they issue proper certificates, and this is a centralized trust. If you have proper certificate authority infrastructure within your organization, this should be a pretty attractive option. A lot of people don't have that. Another problem is that you'll be duplicating the certificate in every single event. So the increase in event size when you're signing and just include the signature, I said 50%. Obviously, it depends a lot, but certificates are significantly larger than just the public keys. So you would see a fairly substantial increase in event size, which would affect storage and so on. Well, transmission bandwidth too, but I don't think that's such a big problem for people. Otherwise, I think this is a pretty attractive option. And the good thing about this option and in general, solutions that rely on using certificates is that certificates, they are issued to someone, the subject in the certificate. So you would then be able to actually verify this against the identity, the sender identity included in the event. So it's a pretty good option. So it's not just, without that thing, you would only be able to know that, yes, this was sent by someone, someone trusted, but I don't actually know who. But subject in the certificates, make sure we know exactly who it is. And the third option that I think we're going to go for, at least initially, is that each consumer would have configuration that includes the public keys. The simplest solution is just to copy the public keys of all the people you trust into whatever configuration you have. That's really simple. But scaling that is not great. How should those keys be distributed? What you could do do I have? No. Oh, wait. Yes. Yes. I was getting ahead of myself here. Another option is to have shared configuration with the keys. So you would have one central location, either a source code repository or some file you could download from somewhere that contains the keys for everyone that's authorized to do this. One potential problem there is how do you then that file, wherever it is, or set of files, would be very, very security sensitive. So if you would have it in a Git repository, for example, you would have to very closely guard who would be able to make modifications to that repository. What you could do to limit that risk is, again, don't just use the public keys, store the certificates there as well, because then you get both similar to if you included the certificate in the event themselves, you would be able to verify that this is someone I trust who issued this key and it belongs to this exact identity. So I think that's probably the long-term solution that we're going to go for. I think that's, yes, any questions or other comments?
So what happens if a message is rejected by the consumer? Is it left on the message bus then and polluting the message bus or the message queue?
If a message is rejected, it will be, well, let's see. Unless you have set up dead letter queues, it will just be removed. But if you set up dead letter queues, it will be routed to the dead letter queue, if I remember correctly.
Okay, so I was thinking it could make sense to just prevent messages from entering the message queue if the signature is invalid.
Here, where the suggestion was to make an event submission service that would use mutual TLS for authentication of the requests, and then you would use the same certificate for the signing. So a sender would only have to keep track of a single certificate. They would use it for authenticating itself to the web service for the sending itself, and the web service will then also verify the signature using the certificate that they presented. So that's definitely one option. Unfortunately, no code has been written for that yet, but I think that would be quite attractive and would get around some of the limitations with the current event sender service that we have, RamRam, which wouldn't support, let's see, well, it has, how about the publish message endpoint of RamRam? Does it tamper the message at all? Or is it just straight pass-through? Okay. In that case, you could use RamRam for sending signed events, but not the endpoint that generates the message and sends it. That doesn't work. Any other questions?
I got one question. Is there any users yet for this one in practice?
Are there any users yet in practice? This is one question.
We have one service that signs and sends signed events, but nobody cares about whether they're actually signed yet. Give me a few weeks. But we were at least exercising the proper code paths. So we were definitely in the starting phases. So that service, which is going to be responsible for all our really artifacts, we thought it was pretty relevant to have those signed, and then all the Jenkins events are gonna be signed as well. And then we're gonna use signing in more places, but that's at least the two starting points and the most important ones.
Thanks.